Sounds like it, yeah, it's quite odd. Someone is in this. Cool. Let me just say a quick few things about number one. So you're given this improper integral. You need to do a change of variables. So remember, just a quick reminder of how to do that. You can replace this x here with 1 over u, but you still have to do the differential change. So take the derivative of this. First write it like that. Then you'll have something here, du. You just make that sub here, and then that sub here, and then the integral will be cool. But notice that we're converting to a 1 over u, and you still have to change the limits as well. And the limits are going to turn into 0 to 1 on this integral. When you first change them, they will look like this. What do you have to do to flip them? Because the 1 over 1 goes to 1, 1 over infinity goes to 0. How do I change those so it's 0 to 1? What do you do to the integral? Yeah?
You make it negative.
Make it negative. So you're going to have to remember, you're going to have to put a negative sign in there because you want it to go lesser to greater. This is going to be your A, this is going to be your B. So first problem you're probably going to encounter is when you go to the trapezoid code. You go to that old trapezoid code. I have this function in the sample that I gave you that says f equals np dot sine, because we use the sine function, but this is just like a pointer to the function, and it's not going to work when you put your function in. You're going to put this integrand in here. So what you want to do is rewrite this as a definition. So you're going to say def f of x colon, and then you're going to say return, so a little space here, just a tab or a space, return your formula. And that formula is going to be this blah right here. Keeping in mind also that exponentiation, because you're going to have powers, if you want to say x to the n in Python, that is x asterisk asterisk n. Keep that in mind because that can barf your code up. And then even if you do this properly and you go to run the code, you will get a division by 0 error because the lower limit here is 0. So what you need to do is set the a. So don't use a equals 0, but we'll just make a as small as possible. Instead, set your lower limit a to the smallest positive, just a super small positive number. And that'll work just fine. So with those things, that problem should roll pretty well. And if you have any questions, of course, ask me. Again, I'll be in tomorrow, I'll be in Friday, be in Monday. I haven't figured out when Monday yet, but I'll let you know.
I had a question that also goes with number
Yeah.
one. In part B, it says shift the integration points from -1, 1 to 0, 1.
Yes.
Shouldn't that be from 0, 1 to like switch?
No, so the Gaussian nodes that you'll look up in the table,
Yeah.
those run from -1 to 1.
Yeah.
And so we need to convert them into our nodes, which will be from 0 to 1.
So you take integral, your blah thing you have on there, and you
Yes.
shift it
Yes.
to like blah 2, but instead of 0 to 1, it's -1 to 1.
No.
No?
So let me line this up. So your Gaussian nodes would work great if you had this integral. So they're built for this integral. And so you've got in here equals, so let's put dx blah equals the sum of the weights times the nodes as given.
Yeah.
So what you're going to change those to, Eva, is you're going to change that to your weights are going to stay the same, but your nodes need to be shifted so that instead of being here, they are for 0 to 1.
Okay, so you don't do anything with the integral, you just change it.
Right, exactly, yes.
Thank you.
Exactly, does that help?
Yeah.
So here you're going to put your shifted scaled nodes,
Okay.
x of i's. Does that help?
It helps a lot.
Okay, awesome, cool. Thanks for asking. And again, you don't change the weights. The weights remain constant.
You said you don't change the weights?
I'm sorry, what?
You don't change
You
the
do
weights?
not change the weights.
So you shouldn't put 1/2 up front.
Well, this, where'd you get that 1/2 from?
Cause I thought you had to like, because you're scaling by 1/2.
Mm-hmm. Well, this is gonna go in the notes, so that 1/2 came from,
But I changed the points then.
yeah, and this is fine.
Okay.
So use these points here with the weights as given.
Okay.
So in other words, so you've already done, if this is the 1/2 that plus 1/2, then you're done. So when you come over here, Cormac, you're just gonna have just, yeah, literally just that. You know,
Okay.
you've already done the half part. Does that help?
Yeah, I
Okay.
was just confused because it seemed like it was so far off.
Was it?
I don't know, I can
Yeah, check it out.
check it out.
Wow, I don't know what's going on. Okay.
He's doing something.
I'm gonna come over here real quick. Excuse me, thank you. Yes.
So, did the change
Mhm. Yeah, that's the right way. Yes, that's perfect.
It's like the transform the point to is
Mhm. Hmm. Wow, that is pretty high. Wow, that's terrible. Shit, sorry. No, I'm sorry. There's a lid on it at least, my goodness. Yeah, that is concerning. Hello. Welcome back. Yeah, yeah. So what's the 1/2 out in front from? Hmm?
I followed today is a formula that they have,
Yeah, I would think so.
textbook.
Yes, and you do, so you've already done the half part in here. So the 1/2, when you took this, that's the half.
So I told him to.
You don't need that half out front. That was what Karmic was doing as well.
Oh, okay.
Yeah, yeah.
But isn't, they also have that 1/2 out here, so.
Let me look.
So that's P. and that's
Yeah.
K. So they also do that
Hmm.
out there.
Oh, yeah, because of the differential change. So bless you. Oh, there is a 1/2 out in front. Because we had to change because we do shift everything. Hold on, Cormac, we might have that 1/2 out in front.
Okay.
Yeah. I forgot about the differential change. So we did the whole info. And it was. And then it's also there. Okay. Hmm. Well, gosh, I don't know why that's so far off. That's really, Cormac, how far off? Were you getting a pretty far off answer?
0.28414, which is pretty far off.
That's, yeah, I mean, that's kind of close to what Vivian's got, but it's actually, I wonder why you both are getting such different answers. I need to check that out. Let me go sit down and work this real quick. Oh boy, now it's gonna get really tough. I gotta do it, I'm gonna have to, hey, Christian, next time.
I know I just got here, but it's okay.
Yeah, yeah. I mean, this is like, okay, you do you. You do what you gotta do. Alright. So Eva, just a really quick note. There is, because when you do the shifting, you're actually shifting the whole integral when you do. Oh, no. Oh, yes. Okay, we're okay. Because we got the 0 to 1 from that. So, yeah, we kind of end up moving this thing back to a -1. Yeah, there's going to be a differential change out front, and everybody's kind of getting a half, because your transformation involves a 1/2 on the coefficient on the x. All right, let me just sit down and work this problem through. You doing all right, Lavina? Let me know if you need anything, okay?
I need a break.
Yeah. I don't think I'm the guy to do that right now. Okay, so let's. Do you have, or Sheets, Google Sheets? That would be cool.
Google Sheets is free.
Exactly, cool, yeah, if you don't mind.
Log in.
Yeah, that would be good, thank you. I don't wanna mess with anything.
You're fine.
I appreciate you doing that for me, though, I know you're working. Everything okay?
I just keep forgetting to use my screen paper for my background. It's so stupid.
No, thank you. signing in on my account, so if I somehow forget to sign out, you sign me out.
I'll try to remember.
Not
to
mess
say
with
that
any of
it's
my
on the
crypto
sheets.
log sheets.
Well, I don't open the sheets very often, so I'll probably
Okay,
not
fair
listen
enough.
if they're
Yeah,
logged
yeah.
in or not.
Okay. Yeah, I'm gonna help with this one. I'm just gonna work it through a little bit up here, so just to make sure we're all on the same page. I'm still gonna call this F of U here though, because I want you to find that for sure. So we've got. Still like you to show the work, but I am gonna give you some sanity checks up here and just kind of make sure you understand that this is our transformation. We're converting this thing into x integral, because this thing here needs to be rewritten in this way. Now we're gonna go back to x. You don't have to call it x if that's confusing with the original. It's not the same x. It's a different x than that one up there. So when x is minus 1. Oh wait, no, this is the x. This is the x. So that's it, and then this will be the u. There we go. Okay. No, shit. Son of a bitch. Okay, so when this is 0, when this,
Wait, Dr. T.
Yeah,
Isn't
yeah.
this what Eva was asking about earlier
Yeah.
about
Yes.
taking? Okay,
So
so,
you
is
do
that how
have
you
to
want
do
us to
that?
do it, or is
Yeah.
it the other way?
what do you mean by the other way?
Well,
by
'cause
that
you're talking,
stuff up
yeah,
there?
you're talking
Yeah.
about shifting the points into like. I feel like it's essentially the same thing.
It is the same thing, but I was like, I was thinking of this process here, Lou, and then the end result,
Yeah.
which I think they're gonna be roughly the same, but I wanna like just do
Okay.
it and make sure that we're all
Okay.
roughly
Sorry,
same.
Instructions seemed unclear.
Yeah, they do seem unclear, and I'm being unclear right now as well.
No, you're all good.
Well, I don't know about that. So, I want to transform this into this integral. So when, I'm just going to kind of do it from scratch, when u equals 0, I want x to equal minus 1, and when u equals 1, I want x to equal plus 1. So I think this formula, we're going the other direction, because this transformation does not, this is going backwards here. So I think what we want is actually kind of the inverse of that transformation up there. In other words, I want to take the point 0, so here's my u-axis and here's my x-axis, and I think that's why the results are so terrible that we're seeing. We want to take, when u equals 0, we want to get out x equals minus 1. So that's minus 1 there. And then when u equals 1, I want x to be plus 1. So that thing actually has a slope of 2. And I think that's why everything is hosed up completely. Because the Gaussian nodes are for this integral here, so we do have to transform our points into here. so this transformation is actually gonna be, let's see, a slope of 2. So we're gonna have x equals 2u, and then the y-intercept is -1. And I think that's what we need to do, Eva and Vivian, who have asked this, and Lou, now you're in the morass as well. So what we're gonna do is this transformation formula up here. So when we do the actual dx and all that stuff, well, hold on. Yeah, but shit, because I'm going to x here, so dx is 2 du, so du is still 1/2 dx. Okay, wait, no, everything was okay. Everything that seemed okay, so that's where we get the 1/2 from. Because we're gonna replace that with 1/2 dx, and we're gonna replace u with the freaking formula up there. So u is gonna equal, 1/2 x plus 1/2. And and so that was right. So why is this all so weird?
Well, it's not weird when you use the 1/2 dx.
You actually got a decent answer with that?
My error was like 0.00249.
Oh shit, okay, well then that is the right approach, okay.
Yeah.
So you did use this transformation.
I used that transformation
Yeah.
and then had the 1/2 dx.
Oh, okay. So if you just take 1/2 your answer, Viv, you should, because your first answer was what, like 0.3?
First answer was
0.27 something.
yeah, and
0.277.
I had 0.28, but then with the 1/2 it's 0.14.
Yeah, and that's the answer I was seeing for the true answer, like it was 0.13,
Yeah,
something like that. Okay, so we're just missing the 1/2 on the transformation.
Okay.
That's it, okay, cool, awesome, nice sanity check for all of us. Eva, does that sound?
Yeah, that's what I was like
Yeah.
thinking we had to do for the problem, and then you were saying something about the weights, so I ignore everything
Yeah.
you said about the weights.
Yeah, that's fair enough. I mean, so in the end, that's kind of what you end up doing. You could either change this, you're essentially changing the weights by this formula here. So this, what I was saying here, is the 1/2 x plus 1/2. You take the given x sub i's and put them here, but then there's a 1/2 out in front. Does that make sense?
That makes
That's what I was,
writing that.
yeah, that helps,
Write it
okay.
together.
Cool, awesome, glad we're together. And that worked out sweet, okay, yes, sir.
I have a question about that in general.
yeah.
So when I looked it up from a math book and it had it like ax
book?
plus b,
Yeah.
book, fancy stuff.
Mm-hmm.
And it said that the like a part of it was the scalar.
Yes.
So when you have du equals 1/2 dx, would that always be just like the scalar?
Yes.
Okay.
Yeah, exactly. Yeah, your differential, when you have a constant, when I do something like this, and I have like a constant du, that says I'm doing a scaling. But shifting doesn't affect integral values. Yeah,
The scaling.
the scaling does though. Yeah, it changes your area element by that fraction. Yeah, good stuff. What book did you look at? It's very analog of you.
I don't remember. I just like looked
It's
up,
cool, whatever. Yeah.
You find whatever it's called.
But online, right? Cool, okay. I was like, wait, you had a book?
No,
Okay, no.
not that weird.
Okay. Good stuff. How you doing?
Is this one for part B?
This is for, so part A was that part where I went from the integral to the f of blah. So this is part B, yes, this is part B.
So I'm gonna do this.
Yeah, perfect. Yeah, exactly. Yeah, you're doing great. You're doing great. And then, so the only thing you do want to tweak is you had a negative in here already. So when you flipped the limits, because it seems like you lost the negative, but it would cancel with that one. So you actually had no negative.
Just take this.
Yeah, does that make sense? Yeah, like that. Perfect. Does that make sense? Yeah, that's great. Go, but otherwise, you're rocking it.
Okay,
Yeah.
was really interesting.
Yeah, no, it's alright, I got confused too. Took some stupid supplement before going to sleep last night, it was a big mistake. Kind of. I had a dream about freaking Elon Musk, and you think that's a good dream? No, it's terrible. He was as monstrous in the dream as he is in real life.
But somehow I'm not surprised you don't feel enough. For some reason.
I don't like hearing that. I do not like that. You come back for this? Thank you. I got all my problems. I'm gonna log out of Google Sheets. Is this a touch screen?
No.
How come I can't click on that
Oh, it's
tab?
because my phone is frozen.
Oh, okay. I was trying to get
It's
that
really
tab
bad,
there.
it does this a lot.
You gotta reopen it.
No, I need to change the browser, it's just not working for me.
What are you using? Oh, gosh. That sucks. You ever tried Brave?
No.
Oh, Brave is awesome. Brave is, I like Brave a lot. Oh, well then it's fine.
No.
Now you got Google Sheets, you can use it for that problem, it'll be great. It definitely helps. How you doing? No. Yeah. That doesn't seem bad, per se.
Yeah.
What are you working on?
Number one.
Number 1, okay. Do you want me to kind of give you some sanity checks?
Sure.
Yeah, this all looks beautiful.
Okay.
That's perfect.
I guess
That's
what
great.
I'm confused about.
Yes.
So when I'm shifting my integration points,
Yes.
can I just like plug them in place of X?
That's exactly what you
Okay.
should do.
Perfect.
Why don't the weights also go through that transformation? The weights are just,
Coefficient.
they're just the coefficients, yeah,
That makes
they don't
sense.
really.
And then like the 1/2.
I mean, in some sense, the weights kinda do get modified because this 1/2 will end up out front. So, you could think of that as affecting the weights.
Totally. But like the 1/2, that carries over because like
From the different,
transformation.
yes,
like,
from
you
this
can-
transformation right here.
And I kind of think of that as
Mhm.
like being pulled out front. as a
100%.
coefficient. Okay.
That's right.
Right. Sweet. Okay, I'm gonna keep working.
Okay, awesome, you're doing great, you're doing great.
I
Yeah,
have
yeah.
a question
Okay, let's
on
talk.
number 2.
Uh-huh.
We can
It was because I also wasn't quite sure what I was doing. And I don't know what the question was. I'm gonna figure it out.
Okay, that sounds good. Really quick question, on Monday, if I was here from 10 to 2,
That would work well.
would that work well for, that would work for you both? So, is there anybody that doesn't work for, because you have 2 freaking back-to-back finals or something at 10, and you okay, Josephine? Yeah, you'd be okay, okay, cool. All right, I'll be in Monday 10 to 2. Pop through here real quick. Thank you, sir. Appreciate it. I got it. I'm watching. Be careful. Super careful. How you doing? You seem to be rocking it. You even got a table. Work. How are you doing? I said, how you doing?
I'm just rerunning my number.
Cool.
I have everything just like on the computer,
Mm-hmm.
but
It's not coming out right, huh?
no, because this final number that I have already for the 1/2.
Oh, okay, well, let's take a look. So what are you using? So these are original nodes. You're double transforming the nodes.
What?
So up here, you've already transformed them, right? So these are the nodes you want to use.
Oh, so
And
I
then
don't
you're
have to
doing
do
them
it
again, not
Oh
again.
my god.
That's totally why. But you can fix that in there. Yeah. You're so welcome. Hi, what's up? What can I do for you?
So I thought, I remembered learning how to convert like the integral balance themselves to be negative 1 to 1. This, like the thing you guys were doing up there was like converting the actual like Gaussian points.
Yes.
And so,
So it was this right here that we were
Okay.
doing.
okay, and then, I'll just try and do it and see if I can figure it out.
Are you sure?
I mean,
Well, so
I guess-
let's try to get through your confusion. There you go, good.
So it's like, I guess I should like work out the
I'll come back and try.
Yeah,
No, it's okay,
sorry,
it's okay, no,
I'm
it's
just
okay.
like overthinking it.
It's, I think you got it, but it's okay.
Since you're.
Yeah, since I'm here, what can I
Question
do
on
for
the
you?
second
Yes,
one. So for the second one, you say like do two,
ma'am.
things.
Thing? Yes,
2 steps, there it
2
is.
steps, yes, ma'am.
And then at first I was like, oh, you just wanted to go to like slope 2?
No,
But then
no,
I
that's
said
just
that-
one half of it,
Okay,
yes.
so you want the whole thing, like.
Yeah, and you're gonna
twice.
need to do S1, S2, S3, S4
Yeah, well-
twice.
Yeah, okay, cause I
Yeah.
did just S2, was like,
Gotta keep going.
and then I was like, you can't do anything with just S2,
You're
so
right,
then-
you're so right.
So, okay, so the whole thing.
Yeah.
Twice.
I'm sorry.
No, that's alright.
I guess I'm not, cause I chose this to give, but it is a little tedious.
It's okay.
Okay.
I mean, it makes more sense.
Yeah, okay,
Like,
cool. Yeah, cause that,
to
yeah,
it
yeah,
all, like-
absolutely.
Huh.
I'm gonna come around the other side, start down on that end on the other side with my friend. This is a weird, not good setup, isn't it?
Why they chose to do it this way.
Let's fix this. So that you can, I mean, it'll work, make it better for all of us.
It's like they put it in there so you wouldn't move it.
So you
They don't know me very well.
Yeah. Alright, do you need help here? Let me get that shot. There, oh, so much better. Now you're good. Oh, that's so much better. We got our room back.
So much space.
Yeah, so spacious. Hi.
Oh,
Are you? Okay.
I'm writing a 10-page paper.
Okay. Focus.
Nothing.
I trust you to do what you need. With your-
I don't trust them. Just do what she wants to do.
I trust her to do what she needs to do. I don't trust her to come out of it healthy.
Same. That's probably a better way to put it.
Yeah. What can I do for you, my friend?
Honestly, I'm just trying to work through your substitution. I've
Okay.
been it forever, so I'm just like trying to figure out.
Okay, so which one are we doing?
This is just basic.
Oh, you're just doing, okay, gotcha.
I mean, there is this, I don't think it's that, I just.
Yeah, so here, let me give you a little bit of a hint, so, for this one, so you've got this, you're gonna replace that x with 1 over u. To find dx, you wanna find the derivative with respect to u of that thing, and then you're gonna tack a d on it. So you need to use the power rule. Does that make sense?
Yeah.
How do you do that? So let's do it
That's
together.
a great question.
So let me ask you this, if I asked you, what is the derivative with respect to u of u squared?
Just 2D.
There you go, how'd you do that? That's perfect.
Oh, okay, so you just take the exponent right in front.
And then subtract 1 from the exponent.
Okay.
You knew this. Just needed to freshen it up. There you go. Got you on step. Josephine, my friend, what can I do for you? Anything?
Yes.
Okay.
I don't know. I feel like half silly about everything. It's like I read it and I'm like, yeah, no worries. And then I like look back at my notes. I'm like, oh, why is it kind of poo?
That's okay, this is where we're pulling together the pool.
Right. So for the first one, it's kind of rough. But then since you wanted it in like a nice thing with like tables, I was probably gonna clean it up in the text and some more like kind
Yeah.
of scratched work.
So this is just 2 nodes here.
I'm supposed to do.
4 nodes.
Oh,
4
4.
nodes.
Sorry.
It's okay, no sorries, but I mean, this is,
But the
and then, yeah.
is leading into it okay?
And you're using this as your F then, that's great.
Right.
You're the one, yeah, so it accomplishes exactly the same thing.
Okay.
Mhm. Yeah,
So
that
then
looks great.
I just find out what the weights and the things are
Yes,
for
ma'am.
4 of them,
Correct.
and then I use this is
Mhm.
fine.
Yeah, it's a little bit brutal to maybe do it this way. Could I maybe suggest something that would just make it easier on your mind? Okay,
No, it's part of the.
where can I write?
Anyway.
Oh, okay. So I would first, this is great, I would work with this. So let's
And like keep it there, do whatever you want, then substitute.
exactly, so make that F of U, because
4 times.
this is just gonna become like potential for error is massive with that formula, it's gross. So what I would suggest we do is look up the 4 x of i's. So they're gonna be, there's gonna be 2 negatives and 2 positives.
Right, like the regular ones?
The regular ones, yeah, so you're gonna have x1,
Big
x2,
table.
x3, x4. And then we're gonna convert those into the inner, we're converting those from,
Can I not just like?
0 to
yes, so this is gonna be 1/2 that plus 1/2, and we're gonna do that for all of those. So first do this transformation, you've already got it right, but first just transform the points and get a little table of points. And you're gonna get 4 new nodes. Use those nodes along with this F.
Because this is the negative 1 to 1.
Yeah, exactly. So in the end, so it's gonna look something like this. This integral will be, you'll have the 1/2, which essentially is from there.
Yeah.
And then, this is really accomplishing the same thing. And then we're gonna have weight 1 F of that dude there, which is 1/2 this value plus 1/2. So let me just write it in here, 1/2 x1 plus 1/2. It's gonna accomplish the same thing. I just feel like maybe making this table first and then forgetting about
All
this
the stuff.
formula
Okay.
and just using that function there. So you could even make like another, here's F of U, and I'm just plugging those in, getting those 4 points.
So then would it be put the x in as u here? Or
Put the, so let's see, what's the first node? We gotta find it. Could anybody
it's
just,
like a table.
yeah,
0
it's
to 1.
okay. Let's make them up, let's just make some up.
I got 0.14.
Is that-
That's
Is that sound
I just
okay?
need
Okay.
to remember that it's not real when I look at it.
Okay, we'll just, how about we just call them x1, x2, x3,
Yeah.
x4. So I'm gonna make this table of values that's the transformations of each
That's
one
like
of those.
this.
That's essentially that, yeah. So now I've got these 4, use these nodes. And then we're gonna take 1/2, and over here, we're gonna use the weight, the normal weight.
From the table,
Mhm.
and then
And then we're gonna have, we'll call this U1. And then plus W2 F of U2. So these will be our U's right here. And then it just makes things a little, now you just forget about these original nodes completely. You've got these 4 transform nodes. I'm gonna plug those into this thing. It will accomplish the same thing, and I hope I'm not confusing you, but I feel like this just scares me a little.
okay, this is fine.
Does it make sense what I'm
Yeah,
saying?
yeah.
Yeah, okay.
And then for when I put in the code, I would do this one instead.
Yes, yeah, so for the trapezoid rule, then just enter this integral.
And I put 0 to 1.
0 to 1, but make it 0.0000001,
Yeah.
because otherwise you're gonna bar this at 0.
Okay,
Does that make sense?
yes, and then I started
Yeah.
on the second one,
Cool.
and then,
A little like triangle.
is x the same as like
It makes
t, or is that like position x?
That would be t here, yes.
Okay,
Yeah,
okay.
exactly, yeah. Oh, well, wait, let me look at the problem. Yes, because this is dy dx.
Okay.
So if you
okay.
wanted, this could be dy dt equals t minus 2y.
Cool, I'm just making sure.
Yeah,
that's
no,
what
it's
the-
good, good sanity check.
Okay.
Is that all you need for now?
Yes.
Awesome.
It might just be really
I-
slow. For number 3.
Yes, sir.
So you have that, and then change it to that.
cause you, yes.
Mhm.
Yeah.
That.
Yeah,
And so you
perfect,
put it in
yeah.
here like this. Does that look?
I think which code, this is not the code you wanna use for that problem.
We're not using.
We need to use the system code. So the modified RK method is just for first order, one dimensional.
I think. Wait, is it?
So it's the, I don't think it's, yeah, no, it's not this one, it's the other.
Is it called?
It's second order,
Oh, the
second order solver.
Okay,
That's the one
probably
you
what
wanna
I was
use.
confused.
Yeah, absolutely, cause there's no, you're like, where's the system? So now you can see the system right there. And
This
that,
one?
yeah, this thing right here.
X as far as dx dt.
You see now?
Yeah.
Does that look a little better?
So. Yeah. I just gotta work it.
You gotta tweak it a little,
Yeah.
but just remember your mass is, your mass is one, your K is one, and your mu is one.
Mm-hmm.
And so when you come down here, and set
Ah,
those right
there
here,
it is.
yeah, and like
Okay.
basically,
So you don't.
you
even
don't
have to
really
transform it
need
like
to,
that.
you do for me to, on the paper, but not for the code.
Gotcha. You can just use this.
Correct. Does that make sense?
Yeah.
Cool. Yes, for problems 3 and 4, please use the second order solver. That's the code you'll need. You don't use the RK method code. Second order solver for number 3 and 4. I'll put that on the board.
That's the one with like the damp oscillator in there already?
Yeah.
Okay.
Yeah, yeah. So it's, you don't really have to do much to
No.
the code to run problem 3. It's like,
That's the one I was using to do problem three, I wanna make sure.
yeah, absolutely. Yeah, yeah. And just change the M and the K and the mu.
Yeah,
Or change one of them, I think.
whatever.
Yeah, whatever, yeah. And feel free, if you get stuck on anything, your code's not running, send me, cut and paste your code into an email, send me that question anytime. Oh, I'll be checking email all weekend. Yes, you're right there, Will.
Yeah, I was wondering was that right. And I had a question about this one because it was asking to break it into like a coupled system.
Yes.
And I guess I just wanted to see if this is what you meant because I couldn't think of any other way to like break it down other than like in the other problems where you have like
It's
the
kind
velocity.
of like this, but we need two differentials. So
Okay.
here you've got d theta dt. So actually, what I would just say, you have it right here.
Okay.
It just, this is theta dot.
Yeah,
So,
I wasn't sure
right.
if you wanted me to keep.
Whatever.
Yeah, okay.
I would make it consistent
Okay.
between these
Yeah.
two, so pick a
Okay. No
notation.
biggie.
So
Okay.
theta dot equals omega,
Yeah.
and then omega dot equals move that stuff to
Okay.
the other side.
Cool.
Otherwise, it's
Yeah.
pretty much
Okay.
exactly correct.
Yeah, and then I'll do the same thing.
Okay, that looks good.
Okay.
Yes.
Perfect.
Nice, you're like almost done.
Yeah, I was doing all the coding stuff. I just was waiting to do the stuff back here. It's slow and tedious.
Truly. Making second round. How you doing, Vivian? Did that work out?
Yeah, it worked.
Oh, fantastic. Fantastic. Thomas, I'm back.
Did your name Thomas?
What's the book?
Absolutely. This, yeah, that's what we got here.
Okay, so
This looks great.
Well,
Except that you don't want the UIs.
Oh,
you want
use the
These are
XYs.
going to be the nodes as in the table. So,
the table like from.
you get, or just find a table of the Gaussian
Oh,
coefficient,
yeah.
or you can compute them with cosine.
Yeah, I just like remember I looked them up.
Yeah, yeah.
I have it.
Yeah, that was right up.
I mean, I remember I
It's
found
open,
them.
it's
The whole
on
thing's.
the.
It is, it's
After
completely
doing
open.
the surgeon.
Yeah, I mean, yeah,
That's just not
yeah.
understand
Could you send me that table?
Sure.
Thank you.
How far do you want it to go? Like in
Oh,
terms
just
of
up to
points?
N4, just so we have what we need and.
Lou,
Thank you.
Yeah.
Is the mass the first constant or the second constant?
Yeah.
Yeah, there you go, yeah.
For which one? Which problem are you working
And
on?
then you do like
Dot
three,
X
go down
Oh.
the next line,
Which
which
one's
have
mass
over,
and which one?
it's return. F of X, right?
I think X dot is mu.
Yeah,
They
that's-
should just all
that's
be
it.
one.
That's it.
Yeah, but I was just saying returns are.
Yeah, fair enough.
What's
That's
the-
right, 'cause that's
Yeah,
where we.
it
So
should
like there's
be
no
Mass.
mass mu.
Terrible.
Straight
They
constant.
for
for,
some
I
reason.
have like the invalid syntax there.
It's your even.
Okay, I'll look at it. I found one on Wikipedia before, but I can't find it again.
You don't
Yeah,
Thank
no
you.
worries,
You don't need the F of X.
Oh, really?
I was just doing with.
You just like, it doesn't.
Four.
What a nice person.
When you do that,
Okay.
because the return is what
Is
you're
like
the
the-
define, because you're calling it and then
There you go.
returning what.
So
Okay,
these are the points, these are the
I got
X,
it.
these are weights, and then these are the X's, and those are what are gonna go in place that you want. So just notationally, I would keep that as.
Yeah,
I gotta tell you.
yeah,
Does
I
that make
tried to
sense?
have like this
Yeah.
to you because I had switched this to you and then I made it a Y to be like
one point.
Thank you.
Fair enough.
I don't know,
Fair
I can
enough.
change it, I'll probably
It
change
doesn't
it.
matter, but you understand where to go next.
Yeah, so like.
This is beautiful, use
okay,
that as
so
your
I would
F.
plug in this number to this.
Yes.
So
Yeah,
like
and then
one
sum
time.
up, and the weights are already gonna be halved,
Yeah,
so you're good to go.
okay. Yeah, thank you.
Oh, you're welcome.
I heard there's so much lady over here in here.
I appreciate that.
Yes, ma'am.
I don't know why it's considered it's kind of weird.
Oh my
Those are
goodness,
all like.
do you want me to help with your papers?
I just need
Yeah.
one more.
She does.
Oh, word, oh, okay.
Something's supposed to go there that I cannot remember.
Therefore, the people bank dash oh, okay.
Like my brain stopped.
So what is it you're trying to say? Just tell me.
It's like,
Impacted,
And that's what you put in for X bar.
impacted by environmental races, they don't want to buy.
I did, like,
Are
put
suffering,
your integration points in place of X.
Yeah.
And then they, like, give
are
you-
suffering the
Yeah.
harms of environmental racism.
oh, I don't know.
So it's just the ones in the book and you plug it into you equals one half X.
And then we wanna get rid of by, the Bangladesh
Of course.
are suffering the impacts of environmental racism caused by the power-hungry global corporations. Does that sound good?
Yeah.
That's so random.
I can roll a phrase every once in a while.
It's like the most random thing I've heard in the. What's that? It's like the most random thing I've heard.
Yeah, oh yes, okay, yes, oh, that code looks unhappy.
Yes,
It's raging.
I don't really know what I'm doing wrong.
Well, let's see here. It says function. Apparently it's a float.
So I think you're not returning. No, you are, let's see. Are you sure E is a function, or is it EXP?
It might be EXP.
I think that's it. There you go.
Okay.
It's just the XP. Yeah, not E. Yeah, there you go. That's all. It just was like, what do I do with this? Do you see?
Does EXP, like,
That's E.
That is E. That is, yeah, that's computer inline E. Yeah.
would not have figured that out.
Now you know.
Fair
Now
enough.
you know. I sometimes use it in calc to help explain the chain rule with E, because then you've got EXP of something.
Yeah,
Yeah.
that makes sense.
Yeah.
That's how I'm doing this right.
How we doing? Yeah.
Doing decent.
You're rocking it. Yeah.
So I'm just on this
Mhm.
part. When I do the transform thread, I'm just
Yes.
plugging this in.
Correct. 100%. And then, yep, you're rocking it.
Okay, thank you.
Yes.
That's how I get it.
Perfect.
Check.
You got it. Yeah. Can I do anything for you?
Yeah.
Okay.
Now I'm on this one.
Coding.
And I
Oh,
got
this thing is not
that
written.
I like fixing coding.
Yeah, that looks good.
Oh, wait,
I just, so now I'm doing
Did you get
the,
it?
well, I skipped this one.
Yeah.
Because I have to watch the voice.
So, okay, cool, fair enough. So what I would do here, Cormac, is, let's see, so you let theta dot is v. Right, so that's essentially your angular velocity, right? We've got two variables. We've got the angle and then we've got the velocity of the angle. So angular velocity. So this is your first equation, which is essentially akin to that right there. So our x is playing the role of theta
Like the cat from the
there. So you've got dx dt equals v. And then this is dv dt.
That would be negative.
Yeah, exactly. So then just move all that stuff to the right and put that in there as opposed to that expression.
And then saying it's a flow for down here.
Yeah.
Mass is 1, and I was.
What are you doing?
Well, so we're actually gonna, I would recommend stripping away the K. You can leave them in the call, because we're not gonna use them. Hard code these, hard code
That's like
negative,
basically the method.
this, u, so over
Every
here,
language has
just
its
0
own
points,
It'd be great if it was like in
negatives,
layman's
whatever,
terms.
7,
Oh, yeah.
v minus
Line 15.
9.81 sine
I'm
of
surprised I didn't give you
X.
So then it just doesn't.
Yeah, you don't want to use the K and the M and the mu anymore.
I know, it'd be nice.
So you can leave them in the call, and you probably should, because otherwise we'll have to change it when it's called down here. But you can have this thing completely ignore them and just hard code this there.
Okay.
Does that make sense?
Yeah, that makes
And you'll know, you'll want NP dot sine of X, okay.
Thanks.
You're welcome. How you doing? Everything good? Okay, fantastic. Kyle, how's it going, friend? How'd that change variable?
It went well. I think I did the original thing, so I don't have to repeat
Okay.
this, because I chose the -1 out in front, just negative u,
Yeah.
but I forgot to subtract the one.
Oh,
Or
okay,
I
yeah.
thought it would like cancel out, but I was thinking anyway, I
Yeah.
just realized it should be.
Cause this is, yeah, that's gonna be negative, yeah,
Yeah.
and then that's gonna be, 1 over u squared, because you're replacing that dx here
Right.
with that whole expression, and that's negative 1 over u squared dv. So that's the other in there, yeah, and then this integral will be, 0 to 1,
0 to 1, yeah.
or 1 to, actually 1 to 0, and then you'll flip them, and it'll get rid of that negative you have in there.
Okay.
Does that make sense?
Yeah, I didn't write that out fully here, I did it there.
Yeah, yeah.
Okay, I see.
Yeah, you do.
1 to 0.
Yeah, 1 to 0.
And it's.
And you still have the negative in there, yeah, because of the dx going to negative 1 over u squared du, yeah. So change that to negative 2.
Right.
It's not a good thing to say.
Okay, so then I.
Yeah, and this was, this one also be negative 2,
That'll also be.
because it was x squared to begin with. So
Okay.
we're replacing x with 1 over u, which is
Right.
so x squared becomes 1 over u squared.
So essentially that's just e to the negative 1 over u squared.
Yeah.
It's all like the same thing.
100%, yeah.
Okay.
And so now that looks great in du.
Okay.
But, so this is perfect, when you can do your Gaussian stuff with this function right here after you shift the points, like we were talking about.
Yeah.
And then, when you go to the trapezoid code to get the precise value.
Yeah, that's when I realized I was wrong, because I put this equation in and
Oh,
I was
yeah.
having like errors there. But that might just be a formatting thing.
Yeah, that could be.
Python.
Yeah, I would put that negative 1 in a parentheses of its own, just as that exponent there. Yeah, it was, yeah, over there, for the. And that should be negative, you'll fix it all, but, yeah, and then, so when you run this, let A be, oh, you already got it, okay, you're good to go.
Except I guess in this case, since.
No, so, I was thinking yeah, so there's still a negative in there,
There's still a negative.
because of the one, because dx was negative 1 over u squared, so we put the negative there, now put equals, flip the limits, and the negative goes away.
Okay. Okay, I thought
You see
were
what I'm saying?
like,
Yeah,
you
yeah,
just
I
do
thought
all
so,
this.
yeah.
Did you just do one?
And I think that's where the next question is, right, because the A and the B were flipped from what we got there. Yeah, you're almost there.
Which part?
Wait, so if it's flipped like this,
Well,
and
no,
you
Feel like when you're doing like
Well,
the.
so, yeah, so this
Yeah, like
is
the
all
semi-easy
great
part.
right here.
Where it's like
And then we're
waste
gonna
times.
rewrite it like this.
It should be.
When you flip those,
The
all
normal
you
flip
need
it back.
you
Okay,
flip it
so you're
back, and that
transforming
actually
the
reads
decimal
the
points to,
negative.
like 1/2 outside, you know?
That's just one half.
Yeah, I believe so.
Okay.
Like
got
the
it.
right
And so this is the integrated that you're gonna work with.
So the P and Q values are still like correct.
Mhm.
Okay,
Mhm.
okay, I got you.
Yeah, and this F,
It's a lot.
but you're only doing 2 nodes here. This is what Josephine was doing at the start, you want the 4 nodes.
Oh, four.
So find the table, and actually I'm gonna put a table up and make sure everybody's got it, thanks to my friend Josephine.
Okay.
That's, yeah, right there. Yeah, and I think those have enough decimal places for you.
Yeah.
Okay, cool.
Yeah, cause it's 5 decimal places, yeah, yeah.
Yep, yep. Really heading into the weeds.
You're good? You got your paper done now?
Yeah,
Any less? Yeah.
mostly. I'm just like making sure it doesn't look weird.
You good? Did your notepad on the paper, did you punch something up?
No, I have multiple.
Okay, because I was like, that is a level of 4 years.
Is it your actual answer?
Whose bag is that? Is that Eva's?
Yeah,
Oh,
this is my
okay,
bag, yeah.
it's- Okay.
Oh,
Okay,
okay.
okay.
Always ask.
You can ask, yep, I'll be right there.
For when yes thing falls when
Yeah,
that's
now
beautiful.
you're gonna tell me when that
Yeah.
happened. I've got like the setup, I just haven't.
It's just.
It's not so nice.
It's not.
It's not, okay,
It's like
let's take a look.
scratch
Yeah,
work,
let's
and
see.
It's like my thoughts process.
So for number 4,
But I was wondering if, because you said you want this
No, I'm
in
not
decimal
gonna show you.
points, like 5.
Yeah.
I'm not showing.
But I think it would be better if we just keep it in the fraction form.
oh, you're probably right, yeah, exactly for
Because
this.
it's easier to find and use in the K.
100%, but, yeah, and I agree with you, but we're not gonna, let me actually address this up here. For number 4,
Okay, good, 'cause I
and then I know you had a question, Christian, I
Don't
think
worry,
you did, I think I heard that.
help this wasn't.
More so it's so that you should.
Okay, you got it.
Even said she didn't want it right now.
Hey friends, really quick, on number 4, so for problem 4,
Good thing on my part.
you want to use the solver, the 2D, the second order solver. But what you're going to do is, and let's see, what is that routine? What is the name of the function that we're changing, Vivian? Who was I talking with about the sign and stuff? Was that you, Cormac? I can't even remember who I was talking to about what.
Not me.
Changing what?
This, yeah, when we modified the code.
Oh.
What was the routine that we modified? Well, damped oscillator. Yeah. So you've got this function, damped oscillator, and in this problem, you're going to have to derive your system. So let me just make up some garbage. So this is definitely going to be your first equation no matter what, because here where x and theta are going to be, so instead of just changing that to theta, just leave it as x, but treat x and theta as the same when you're converting your theta double dot thing over. And then you're gonna have v dot again. And this is what you need to figure out. So let's just take a look at how this might shake out with a slightly different equation. So let's say I had 7 theta dot plus tangent of theta right there, like that equals 0. Let's just say I have that equation that I wanted to work with. And yours is very similar, right? You've got a sign here instead. Or is it some multiple assign? I can't even remember. Cormac, what was that?
It's 9.81 times 9.
Yeah, so there's some number, yeah, so let's say there's like some k here. Well, okay, we'll put 9.81, what the hell, why not? So you're gonna put in your numbers, and Vivian was leaving hers as fractions just to get extra precision instead of doing decimal approximations, because I think this turns out to like 2/3
Yeah.
or something. in front. But what you're gonna do is your second equation, this is going to become V dot here. So this is V dot for the theta, double dot, plus, Jesus. Sorry.
It's very relaxing. That's a good song, Neil Halstead. It's a great album, really great album.
So then we got this, and theta dot is going to be, wait, what is x dot? No. V, yes, thank you. So this equation, thanks, I should have written that up here because now I'm confused. So theta dot is V, and so this theta dot becomes this V, but then this will be 9.81 tangent of theta is x, there we go, equals 0. So your first equation is this. Your second equation comes from here when you solve for V dot. You're gonna get V dot equals negative 7V minus 9.81 tangent of x. So in that damped oscillator code, you've got this expression down here that has k's and m's and mu's in it. Because the function call actually has some k's and m's, mu's, and I don't know what else is in there, probably just that. But it's got a bunch of other stuff. Don't change that. Just don't, these aren't gonna matter for this problem. We're gonna hard code, we're gonna change that second statement that normally would say, whatever, k over m, v minus mu over m, something like this, x or something like this. So instead of worrying about figuring out what to pass in for k, mu, and m, leave those alone. Whatever you just used in problem 3, you can keep them the same. We're gonna not even use those down here. So when we hard code, what I'm gonna do is actually just hard code in here negative 7.0 from this minus 9.81x. So my V dot equation is gonna look like this, and I'm just gonna hard code those values in, as opposed to trying to figure out what k and m and mu to pass in. Does that make sense, Vivian?
Yeah.
Okay, it'll work.
I was just, because I figured it out.
Oh, and if you got it, don't undo what you've done. You've done some hard work
So
there.
you just need to plug in the numbers that you got.
Yes, yes ma'am. Yeah, so you can just rewrite this whole equation like this, and you'll have different numbers, but one of them's already in perfect form here. You just won't have 7, negative 7. Thanks for asking another great question, Vivian. Thank you.
Answer for C. Dang it.
Yes.
Okay. So sanity check was for number 2 with the MT4.
Mm-hmm.
There's so much work doing it, right?
Yeah, it's looking gruesome enough to be right.
Okay.
Yeah.
What I have been doing, like assuming that my temperature was 0.
I think you are. I can't remember what the formulas were.
Like these ones.
Actually, this looks right because you are grabbing the right things. Yeah.
Okay.
Yeah, that looks good.
Yeah, because I guess the thing I wasn't sure about
Yeah, yeah.
was like I had been running them, like doing these to like kind of transform them.
Yes.
And then was putting them back into this equation to get
Yeah.
those.
Mhm.
Okay.
Yep, that's right.
All right.
That's 100% right.
Sweet.
You're doing it.
And then the H stays like.
Yes.
Okay. Like it wouldn't be one.
Correct.
process, Okay.
Correct. H is consistent throughout the process. Yeah.
And then I guess the like only other question I had on that was when I ran it in Python.
Yeah.
I have like no margin of like 0.2-ish of like error, like if I'm looking for.
I mean, that makes sense. This two-step process is going to be garbage.
Okay, okay.
It's yeah.
Really?
Yeah. I mean, 0.5 is a pretty big leap to make forward in time.
Makes sense.
So
Makes
yeah,
sense.
yeah.
Okay, sweet.
I expect it to be a terrible approximation.
Well, that's good to hear.
Yeah. Let me. I'm gonna get Daniel here real quick. Yes. No, that ain't right. You should be getting like 0.14 approximately. Yeah, let's take a look at what's up. So assuming, and these look reasonable, and then can you show me what you did with them next?
Yeah, it's.
Okay. And then these weights are from the table as well?
They're from the textbook, yeah.
From the textbook.
Makes sense.
Yeah. Yeah, I mean, this looks right, so I guess I'm wondering if your nodes are possible. Oh, you still have to run them through the function. So these are great, but basically you're just integrating like, integral of x dx. So these still have to be plugged into that beast.
Oh.
Yeah. Yeah, so take these numbers, plug those into here, and that's what you're gonna have multiplied by the weights.
That makes sense.
Okay, yeah, definitely.
Alright, you're welcome. Vivian, I'm right there.
Okay.
Because if you want to plug in the numbers for the code,
Uh-huh.
then you have to kind of figure out the mu and the k. But like, where do I find this?
Well, what you could
Because
do,
the mass would be 0.3 or
So-
what you gave.
I mean, if you're wanting to do it by passing in these values, you still can't because you can't get the sign in there. That's the problem. So that's why I was saying to move it, but if you wanted to pass them in, I would make the mass 1, and then whatever, but you're still gonna have to modify it because there's that non-linear part in there. You have theta in the code, but you need sine of theta.
Oh, yeah, that's
Does that make
fine. Yeah,
sense?
let me try.
Yeah. Yeah, do that, and then we'll set m to 1, and then k and mu can be the numbers you'd like to use. Yeah. And maybe just do 1.0. I don't know. It might not even matter, but it, like from back in the days, it did matter.
For C, did you figure out the nodes? Or do you like really explain?
Yeah, all of them were like, for like the integration points.
Yeah.
Yeah, they were all less than 1.
Well, like how much of this? Because I'm getting my 10 with anything.
That doesn't look right.
For one of your points.
Can I take
Yes.
a quick look? Okay.
It's basically 0.
It's not too
Oh, you actually.
Oh, okay, thank you.
Huh?
Yeah,
I got like
appreciate it.
1.6 times 10 to the negative 88.
88.
Yeah.
So this should be sine of x. Because your x is your theta
Part C of number 1.
for your process. So
Which,
if I run it again.
Just the first one.
that one was 0. That one was like just about 0. So that one makes sense, yeah.
Is that a hand up, Kyle? I'm just checking.
No, yeah.
Sorry?
Is your hand up?
Oh,
Okay, cool. No, don't stop scratching your back, man. I just wanted to make sure.
Rest convert. Hold up, is that after you like multiply it by weights
Oh,
and stuff? Like run through like.
This is before the weights.
This should be
Like,
V.
that's just your
There you
integration
go.
point.
That's the problem. You saw it at the same time I did. Yeah.
I did not get that. Fair enough.
No, it's still, because it's kind of,
The answer though, so.
it looks
No, the
oscillatory.
K is feed, but I think, wait, no.
Got
So let's see, are we,
Negative K
Man,
over M
this is
is
confusing.
for the x, and then mu over M is for the.
Did you just do 1 point?
yeah, I think they're backwards, because this should be, this is your 2/3 you want
So
right
like
here,
there's like
right?
4 weights and
So
points
that's
in the book.
x, I think
You
that's
do
the right x.
Each
for this
weight,
one
you
should
multiply it
be-
by that function with the corresponding point.
That's what I'm getting at.
No, because
Oh, then I
theta
got corresponding
is
point for
definitely
the
K,
x.
K is good.
I just did it all in-
The
Oh,
x.
you
Yeah,
did
the
it all at
K-
once, yeah. I
So
thought you were
if
saying
we
that was like your
want
final answer.
the negative 9.81 in front of the sign, then mu needs to be the negative
Yeah, I'm doing the
8.1.
Oh.
That's what I
or the negative 9.81. And so I think that's what's going on here. Yeah, flip the mu and the k.
So is this one right?
Yeah, that should work. It's just your mu and k are backwards. Can you scroll down more? Oh, sorry. Huh. The heck?
I got some pretty stuff when I put in K and U into.
Can we just hard code them and see? Can I just change this
Yeah.
so that it's okay?
Please.
Yeah, okay, cool. So this is gonna be negative, and I like your 1/3 idea. 1 point,
Yeah.
or 2/3, I mean, yes. Sorry, oh, what were you gonna say? I'm sorry.
No, I was just gonna say the V goes with the V, I think,
Yeah,
and the K.
so there's no negative 2/3, and then we're gonna make this negative 9.1. So I'm doing the thing you didn't quite want me to do, but I'm gonna do it anyway, just to see if we get a sanity check out of that. So let's run that. That looks great.
Yeah, that's what I.
Yes, that's pretty, that's right.
Okay. So you want me to use that? Okay.
Just, it works, right? Yeah.
That's what I got at the first.
Okay, yeah. So whatever you passed in the first time, that was okay. And it's what we expect, right, the thing to die out.
Okay.
Did you feel good? Okay, thank you. And now I mean, if you wanna go back to what you had, now at least you know that's what you need to see at the end. Thomas, you have a question, friend?
This isn't but I realized that when I was doing part B, I got excited and solved the whole thing before getting to part C and before writing the table. So is it fine if I do the table after I have the solution?
Sure.
Okay, it's like,
I like it. No, and I don't wanna damp your excitement, so I think that's cool. Yeah. Well, hearing you say you got excited about that integral, so.
Oh, excited.
No, let's just leave it there. You don't need to know. We'll just leave it at that. Eva, are you good?
I think so.
Okay. You're on number 4.
Well, I skipped
Oh,
the rest of number 1. I
Got
got
it.
part A last night and then
Okay.
I got confused and then,
Now you're good.
no, they took that.
You're almost done. Fantastic. That's about the amount of time I was hoping it would take. Yes.
I just wanna see if this is the
It's
right
beautiful.
time. That's a problem.
Oh, I don't know the answer. I haven't solved it yet.
Okay,
So,
yeah, cause I had to do ChatGPT like 7 times. And just get.
I'll try to work it out and
No
give you a
worries.
sanity check,
No
but
worries.
that looks great.
Okay.
That looks pretty reasonable. Let's see. What's your?
Or did you just have to put the function in?
It should be about a quarter.
Yeah, that looks right.
Okay,
Yeah,
that's what I was thinking, I guess.
Yeah.
Okay.
Doing good?
Awesome.
Did you say you're gonna be around on Friday?
I am. I'm gonna be around.
In person?
Yeah, I'll be in person. I'll come in around noon. Would that be good? No?
I probably won't be able to make that. That's
What were you hoping it was? Like 11? Yeah, I'll come in at 11. Yeah, you got it.
Don't worry.
Yeah, I'll come in at 11.